Good day, everyone. We're now going to continue our discussion on matrices. We'll now proceed with the transpose of a matrix. So we'll have two parts on this. Part 1 is definition of the transpose of a matrix, and the next part will be the properties of the transpose of a matrix. So let's start. The transpose of a matrix is formed by switching or flipping the rows and columns of a given matrix over its diagonal. So it means that if A is a matrix with the dimensions m by n, then the transpose of A is denoted by A transpose, either with a capital letter T or small letter t, which is now a matrix with the dimensions n by m, or n times m. Have some examples. So find the transpose of the given matrices. A is a matrix with elements 3, negative 1, 2 in its first column, and 4, 5, 6 on its second column. So if we're going to write the transpose of A, by definition, columns will be rows and rows will be columns. So that is denoted by A transpose. So let's start with the first column of A. That will be the first row of A transpose. Then we'll have 3, negative 1, and 2. So proceeding to the second column of A, that will be 4, 5, and 6 in the second row of A transpose. Okay, let's have another. B is a matrix with elements 1, negative 1 in its first row, 2, 0, 3, 4, and 0, negative 2 in its last column. So B is a transpose with dimension 4 by 2. That means 4 columns, 2 rows. And then the transpose of B will have 2 columns, 4 rows. So we start with the first column of B. That will be the first row of B transpose, 1, negative 1. And then second column, that will be 2, 0. And the second row of B transpose, 3, 4. Third row of B transpose, 0, negative 2 of B transpose. So that means if you have a column matrix, the transpose will be a row matrix, and vice versa. So let us now apply the multiplication of matrices and scalar multiplication using transpose of a matrix. We are given matrices A and B. We're going to find A times B transpose and 3 times A transpose. So A is a square matrix with 2 by 2 dimension, 1, 0, negative 2, 2 on its last row. And B is a matrix with negative 1, 3, 4, 0 on its last row. Let's start finding the product A times B transpose. So by that, we're going to just rewrite matrix A and then multiply this by the transpose of B. Let's start with the first column of B. That will be the first row of B transpose. So we have negative 1, 4. And then second column of B will be second row of B transpose, 3, 0. So from here, we will use the multiplication of matrices as we have discussed before. That is 1 times negative 1 plus 0 times 3, getting the product of the first row of A and first column of B transpose. That will be the first element in our product. And then 1 times 4 plus 0 times 0, that is first row of A times second column of B transpose. That will be the second column, first row of the product. The negative 2 times negative 1 plus 2 times 3, second row of A times first column of B transpose. And then the last element, that will be negative 2 times 4 plus 2 times 0. That is second row of A times second column of B transpose. So in the product, we have A, B transpose is a square matrix with negative 1, 4 on the first row, 8, negative 8 on the second row. So let's try to find the second one. That is scalar multiplication, 3 times A transpose. So if we do that, this is again our given. If we do that, we have 3A transpose. We'll just multiply 3 by the matrix A transpose. That is 1, negative 2 on the first row coming from the first column of matrix A. And then 0, 2 coming from the second column of matrix A. So from here, we will just do the scalar multiplication. Therefore, our final answer will be 3, negative 6 on the first row, 0, 6 on the second row. Okay? So next we will have, on the next video, we will have the properties of the transpose of a matrix. Please stand by.